Hi, Hola, Bonjour, and Salaam. Welcome to Blueprint Bazaar, the place where engineering creativity meets 3D design. In today's video, we are taking on a unique and exciting challenge, designing Minato Kunai in SolidWorks from scratch. This project combines anime inspiration with precise CAD modeling and is a perfect way to practice your SolidWorks skills while having fun. Minato's kunai is one of the most recognizable weapons from anime culture. Its triple blade shape, balanced handle, and engraved markings make it a beautiful object to model for anyone interested in 3D design. In this video, we go through the complete process step by step, starting from the very first sketch, creating the blade body, working on the handle and ring, and then adding the detailed engravings that make it truly stand out. We finish the process by creating a clean and professional render to showcase the final result. This is a great video for anime lovers, engineering students, CAD designers, and hobbyists alike. If you are someone who enjoys modeling creative projects, this will teach you how to use features like revolve boss/base for the blade, sweeps for the handle, and sketch text for engraved details. You will also see how to apply fillets and chamfers in the right places to make the design look realistic and smooth. Even if you are not into anime, this is a fantastic exercise for improving your workflow and learning how to work with curved geometries and ornamental features. Throughout this design, we focus on symmetry and proportion to make sure the kunai looks balanced and believable. The handle is modeled with smooth transitions to give it a proper grip-like appearance, and the ring is revolved to get perfect circular geometry. Adding engravings is an important step as it gives the kunai a unique identity and brings it closer to what you have seen in fan art and other concept references. The final render highlights every detail and is a satisfying way to wrap up the project. This kind of project is perfect for anyone who wants to improve their design skills while working on something interesting. You can use the same approach to design other props, knives, or even original tools. It is also a great idea for anyone who wants to practice for 3D printing projects, as the finished model can be exported and printed as a collectible or display piece. Minato Namikaze is a beloved character in the Naruto series, known for his speed, intelligence, and leadership as the fourth Hokage. His kunai is an iconic part of his design, instantly recognizable by its unique triple blade form and engraved writing. This weapon is not just a piece of equipment. It represents precision, skill, and elegance. By recreating it in SolidWorks, we are not only modeling a cool object, but also paying tribute to one of anime's most memorable characters. For anime enthusiasts, this model is a perfect way to bring a piece of the Naruto world into a technical, real-world format. For CAD designers, it's an opportunity to tackle a design that combines symmetry, ornamental engraving, and mechanical form. The curved geometry of the blades, the balance of the handle, and the detailed text all present a good challenge for sharpening your SolidWorks skills. Our approach is methodical and clear, so you can follow along even if you are still learning the software. We start by defining the correct proportions for the blade to ensure a clean revolve, then carefully apply cuts and fillets to create a realistic, polished look. The handle is modeled with a sweep to make sure the grip feels natural and not too blocky. Finally, the ring is revolved and joined seamlessly to the handle, completing the classic kunai silhouette. The engraving process is one of the highlights of the video. Using the sketch text tool, we show how to position and size the text to achieve a crisp, believable mark on the blade surface. This is a great skill to learn if you ever want to add logos, serial numbers, or decorative patterns to your CAD models. The final render is set up with proper materials and lighting to make the kunai shine and look like a finished product that could sit in a collector's display. This project is a great example of how engineering tools like SolidWorks can be used not just for industrial design, but for creative, fan-inspired projects as well. It's a reminder that CAD design can be fun and artistic while still improving your technical ability. Whether you are a student looking to build a portfolio, a professional wanting to practice new techniques, or a fan who wants to see a favorite item come to life, this video has something for you. The kunai itself is a symbol that represents both creativity and craftsmanship. While in anime it is used as a weapon, in reality it has a very unique history as a Japanese tool originally designed for farming and masonry work. Over time, popular culture adapted its shape into something much more dramatic, and it became a well-known prop in manga, anime, and games. That transition from a humble tool to a cultural icon makes it a perfect subject for CAD design. By modeling it in SolidWorks, we are essentially bridging history, art, and engineering in a single project. In the world of anime, the kunai design we are working on is particularly well loved because of its distinctive three-pronged blade and the way it stands out compared to traditional single-edged kunai. For fans, it is more than just an accessory. It's a signature design that carries identity and recognition. When recreating this in CAD, attention to proportions, angles, and blade symmetry is very important, because these are the features that make it so recognizable. Even small details like the curvature of the edges or the balance between the handle and the blade can completely change the overall look. One of the most interesting parts of this project is the engraved markings. These inscriptions are not just decorative, they add personality and storytelling to the model. In SolidWorks, this step becomes a great way to learn about sketch text, curve-driven text placement, and precise extrusion depths for engravings. The beauty of CAD is that you can bring flat sketches to life, adding depth and shadow that give the kunai a real-world presence. This is where anime-inspired creativity meets solid engineering design. The render at the end is not just about making the model look polished, but also about presentation. Think of it like showing a finished prototype to a client. Lighting, reflections, and material finishes all contribute to how the final object is perceived. By experimenting with different textures, such as brushed steel for the blade or a matte finish for the handle, we can make the kunai look closer to what we imagine from anime art. This also gives viewers a chance to understand how rendering can completely transform a simple CAD file into something visually striking. Beyond the modeling itself, this project is also about inspiration. Anime and CAD may seem like two very different worlds, but when combined, they show us that engineering can be creative and storytelling can have a technical side. Many designers and engineers today take inspiration from pop culture when building prototypes, concept products, or even functional tools. The Kunai project is a great example of how ideas from entertainment can inspire the next generation of CAD users to explore, design, and innovate. Another fascinating detail about this design is the way it balances between realism and creativity. When working in SolidWorks, you are not just copying a drawing. You are interpreting proportions, surfaces, and edges to make the object both accurate and visually appealing. For example, the three extended blades can be modeled with precise sketch profiles and revolve features, but you also have to adjust their angles to maintain symmetry and sharpness. This makes the project a true exercise in precision. The handle, on the other hand, gives you a chance to practice sweeps and lofts because it transitions smoothly from a narrow grip area to the circular ring at the end. That contrast between sharp blade geometry and smooth handle surfaces is what makes this design both challenging and fun. When approaching the engravings, it is important to think like a designer as well as a storyteller. In CAD, engraving is often used for logos, serial numbers, or technical markings, but here it becomes a creative element that communicates identity. The Sketch Text tool in SolidWorks allows us to replicate these markings along curves or flat faces, and careful depth control ensures they look like real etchings rather than just surface prints. This step also highlights how CAD can be more than functional. It can bring cultural references and artistry into engineering. The modeling of the ring at the end of the kunai is another interesting aspect because it challenges you to think about both functionality and aesthetics. In SolidWorks, this part is best created with a revolve, giving you a perfectly smooth and circular geometry. However, it's not just about making a simple ring. Adjusting the thickness, inner diameter, and edge treatment changes how it looks and feels as part of the design. By experimenting with chamfers or rounded fillets, you can give the ring either a sharp, weapon-like quality or a softer, ornamental finish. This teaches a valuable lesson in CAD. Even small changes in geometry can dramatically affect the overall personality of a model. Anime as a genre is filled with objects that carry meaning beyond their practical use, and weapons like the kunai are a perfect example. They are not simply tools for battle, but extensions of a character's style, personality, and story. In many series, a character's weapon becomes as iconic as the character themselves. When you see a certain blade, shuriken, or kunai, you immediately associate it with the emotions and moments you experienced while watching. That is what makes projects like this one so captivating for designers. We are not just modeling shapes, but recreating symbols that have strong cultural resonance with fans around the world. The kunai, in particular, has a special place in anime communities because of its unique design compared to other common ninja tools. Traditional kunai are usually plain and single-edged, but the one we are recreating stands out with its distinctive three-pronged blade and perfectly balanced proportions. It is a design that looks both functional and ornamental, something that could be wielded in battle, but also displayed as an artifact. When fans see this design, they instantly recognize it and recall the moments in anime where it played a part in fast-paced action sequences, strategies, or emotional story arcs. That instant recognition is what makes it such a fun subject to bring into SolidWorks. There is also a deeper cultural layer here. Many props in anime are based on traditional Japanese tools, weapons, and symbols, but they are often exaggerated, stylized, or given unique features to stand out on screen. This transformation mirrors the way CAD designers often take real-world references and adapt them to new creative purposes. In a way, anime artists and CAD engineers are doing something similar, taking inspiration from the world around them and reshaping it into something unique. By modeling this kunai in SolidWorks, we are stepping into that same creative cycle, reinterpreting an anime icon through engineering design. For many anime lovers, the emotional connection with these designs is as important as their aesthetics. A kunai is not just a piece of steel. It might represent courage, determination, or loyalty, depending on the context of the story. Fans often admire how such simple designs can carry so much symbolic weight. When recreating it in 3D, these emotional associations give extra motivation to get every curve, every angle, and every proportion just right. It becomes more than just a practice exercise in CAD. It becomes a way of honoring something that has inspired millions of people. What makes this even more engaging is how anime often presents these weapons with great attention to detail, showcasing them in close-ups, dramatic sequences, or as part of a character's signature moves. This level of visual detail translates perfectly into CAD modeling, where precision and clarity are everything. When you zoom into a blade edge or the engraved markings in SolidWorks, it feels like those cinematic anime close-ups where every reflection and line is highlighted. That crossover between animated storytelling and technical modeling helps create a stronger connection between the art form and the engineering practice. By immersing yourself in these details, you start to notice things that casual viewers might overlook. For example, the spacing between the blades, the taper of the handle, or the balance between the ring and the body all contribute to why this design looks so iconic. Anime stylization is often subtle in these ways, and when you break it down in CAD, you gain a deeper appreciation for the artistry behind it. The process of modeling becomes not only technical work, but also a way of analyzing and celebrating the design language of anime itself. The popularity of these designs in fan art, collectibles, and cosplay shows how deeply they resonate with people. Many fans build or 3D print replicas of their favorite anime props, and modeling the kunai in SolidWorks puts you right at the heart of that creative culture. It is more than just engineering. It is participation in a global community of fans, makers, and designers who find joy in bringing anime concepts into the physical world. By adding engravings, experimenting with textures, or even modifying the design with your own personal touch, you can create a version that feels unique to you while still paying tribute to the original inspiration. Anime thrives on imagination, and CAD thrives on precision. When the two meet, they create something powerful. Designing this kunai is proof of that. It starts as a flat idea from an animated world, but through SolidWorks it takes on weight, depth, and realism. It can be measured, modified, and rendered until it looks ready to hold in your hand. This is the kind of project that shows how storytelling and engineering are not separate worlds, but rather two sides of the same creative process. Another aspect that makes this kunai fascinating is the role it plays in shaping atmosphere within anime scenes. Often, the presence of a weapon is not just about combat, but about building tension and anticipation. The moment a kunai is revealed or thrown can mark a turning point in a battle, signaling strategy, precision, or the arrival of an important character. This kind of cinematic emphasis is part of what gives the design its iconic status. When we recreate it in CAD, we are essentially taking an object that carries all that dramatic weight and transforming it into a tangible model that can be analyzed, modified, and appreciated in a new way. Anime has a long tradition of using symbolic objects to connect viewers with the emotional journey of the characters. The kunai, with its sharp edges and bold silhouette, embodies themes of speed, accuracy, and sharp thinking. It may look like a simple blade, but fans know it carries significance far beyond its physical form. Translating such an object into SolidWorks is not just a technical challenge, it is an exercise in capturing the essence of what it means in storytelling terms. Every line and curve in the model has to reflect the sense of elegance and danger that fans associate with it. The engraved markings add another layer of symbolism. In anime, engravings often serve as more than decoration. They can represent heritage, power, or personal identity. This is why they are such an important part of the design and why their inclusion in a CAD model makes the project feel complete. SolidWorks allows for precision in engraving, but it also forces you to slow down and think about placement, depth, and style. It is in this stage that the project truly merges engineering and artistry, giving the blade personality and connecting it to the traditions of anime storytelling where even the smallest details can carry meaning. Another reason this kunai is so appealing is because it sits at the crossroads of fantasy and realism. Anime often exaggerates designs to make them more striking on screen, and the three-pronged shape of this kunai is a good example of that. It looks more dramatic and intimidating than a traditional kunai, and yet it is still grounded enough in real-world design principles that it feels believable. This balance is exactly what makes it enjoyable to model in SolidWorks. The sharp edges and bold proportions push the limits of design, but they remain achievable in a CAD environment where precision and function still matter. When viewed in the context of anime battles, this weapon also highlights the creativity of the medium. A kunai is not just thrown, it is often combined with strategy, speed, or even special techniques that make it more than just a tool. Fans remember these moments not for the object alone, but for the emotions attached to them: excitement, suspense, or admiration for the character's skill. By modeling the kunai, CAD designers tap into that same energy, experiencing the design as more than just geometry. It becomes a reminder of the storytelling power that anime objects carry with them. Another fascinating point is how anime objects like this kunai transcend their original medium and become cultural artifacts in their own right. Fans across the world collect replicas, wear them as part of cosplay, or display them as symbols of their connection to the story. This is why modeling the kunai in SolidWorks has such broad appeal. It turns the process of engineering into a way of participating in a global fan culture. The design becomes not only a digital model, but a bridge between technical skill and cultural appreciation, allowing creators to contribute to the ongoing celebration of anime icons. The very act of recreating this design in CAD also shows the versatility of engineering software. While SolidWorks is primarily seen as a tool for industrial design, product development, or mechanical engineering, projects like this highlight its creative side. It proves that CAD can be used for art, culture, and entertainment just as effectively as it is used for machines or structures. This realization is inspiring for many students and hobbyists who want to push the boundaries of what CAD can achieve. Designing a kunai is more than just making a model, it is a statement about the endless possibilities of engineering tools when combined with imagination. What truly makes this kunai stand out in anime isn't just its design, but the way it behaves on screen. Unlike an ordinary throwing blade, this kunai often carries an almost engineered elegance, a tool that seems designed for speed, balance, and precision. Its aerodynamic shape allows it to travel smoothly through the air, always hitting with accuracy. When modeling it in SolidWorks, this same aerodynamic logic can be explored through curvature control and surface continuity, ensuring that every edge looks sleek and intentional. The central spine of the blade, the symmetrical prongs, and the perfectly aligned handle all suggest a design built for movement, something that looks ready to slice through both air and light. Another cool aspect is how the kunai is portrayed as a multi-purpose tool rather than a simple weapon. In anime, it is often shown being used in inventive ways, as a close-range blade, a thrown projectile, or even a utility item during intense missions. That adaptability gives it a special mechanical quality, almost like a piece of tactical equipment. When recreated in SolidWorks, you can appreciate how its proportions make sense, both functionally and visually. The short handle provides a stable grip. The wide base ensures weight distribution, and the pointed ends are perfectly aligned for throwing. Each of these traits can be measured and modeled precisely, turning what appears as an animated prop into a piece of design logic. One of the most fascinating parts of the kunai's appearance is its flawless symmetry. The three-pronged design isn't just for style. It visually conveys control and balance. In the world of CAD, symmetry represents perfection, and achieving it requires careful constraint management and clean geometry. In SolidWorks, you can use the mirror feature to ensure every blade prong is identical, maintaining perfect alignment from one side to the other. This level of precision reflects the kunai's on-screen perfection. No matter how it spins, it always looks even and centered. That subtle detail is what makes it satisfying, both to animate and to model. The engravings and symbols carved along the blade in anime often glow or emit energy, adding to their mystique. From a design standpoint, these markings introduce another layer of depth and craftsmanship. They are etched with purpose, following the flow of the blade and complementing its curvature. When recreating them in SolidWorks, using tools like sketch text and wrap or split line can replicate that same look of controlled engraving. It transforms the plain surface into something that feels alive, with every marking carefully embedded into the form. It's a technical challenge, but one that brings the model closer to its anime counterpart's authenticity. Another signature feature that captures fans' attention is the circular ring at the handle's end. In anime, it serves multiple visual and functional roles, sometimes used for grip, balance, or attachment. It's often shown spinning in dramatic motion, catching the light in just the right way. From a CAD perspective, the ring is an excellent study in revolved features and surface finishing. You can experiment with rounded edges, brushed metal textures, and shadow play to make it visually pop in renders. The ring gives the design a mechanical completion, an anchor that ties together the form and balance of the entire kunai. Even the proportions of the kunai are part of its appeal. Its blade-to-handle ratio is crafted to look visually powerful but ergonomically believable. The handle is thick enough to suggest strength, while the prongs taper elegantly into points that look razor-sharp. For SolidWorks users, this provides a perfect opportunity to practice controlled lofts and fillets to achieve those graceful tapers and smooth transitions. Every contour tells a story. The wide base hints at stability, while the converging points suggest speed and precision. That's the balance of aesthetics and function that anime designers capture so well, and CAD lets you recreate it with mathematical perfection. Another underrated feature is the way light interacts with the kunai in animation. Its surfaces reflect flashes during battle sequences, giving it a dynamic presence on screen. In rendering, this effect can be achieved through material experimentation. Using a polished stainless steel texture for the blade, a satin metal finish for the handle, and soft studio lighting can make your 3D render feel cinematic, almost like a freeze frame from an anime fight. This kind of rendering isn't just for presentation. It teaches the importance of surface treatment and how light defines a design. The kunai's compactness and versatility also make it a symbol of clever engineering in the anime universe. It looks simple, but every curve and cut has a purpose, just like in real-world design. For example, its broad center adds mass to stabilize throws, while the triple blade structure disperses impact and creates an unmistakable visual signature. Translating these ideas into SolidWorks not only strengthens your modeling skills, but also enhances your design intuition. It trains you to see function within form, to look at shapes not only for beauty, but for how they perform. Finally, what makes this design so captivating is that it feels timeless. Even years after its introduction in anime, fans still recognize it instantly. Its look is futuristic, yet grounded, symbolic, yet mechanical. The kind of design that continues to inspire digital artists, prop builders, and engineers alike. Recreating it in SolidWorks is not just about building geometry. It's about capturing that spark of creativity that anime ignites in its audience. It's about taking something born from imagination and giving it real shape, real form, and real presence through design. In the series, the kunai becomes far more than a simple throwing blade. It is an extension of Minato's speed, intellect, and precision. Each kunai is crafted with seals that allow him to move instantly from one point to another, turning the battlefield into a space where distance loses all meaning. When he throws his marked kunai toward an enemy or into the terrain, it becomes an anchor point that he can appear at in the blink of an eye. This makes every fight unpredictable. His opponents never know where he will strike next. The brilliance of this technique lies not just in speed, but in the strategy behind how he places and uses his kunai to control the flow of battle like a master tactician. What makes Minato's kunai even more fascinating is how it channels chakra in a controlled and efficient manner. The weapon itself acts as a conduit, capable of carrying traces of his energy. This allows it to resonate with his unique chakra signature, giving him both awareness and precision when activating his movement ability. The engraved inscriptions on the kunai are not mere decorations. They function as complex seals that store and direct chakra. From an engineering perspective, this is similar to embedding circuits or runes that enable data transmission or energy flow. The anime portrays it beautifully: glowing marks, seamless transitions, and perfect synchronization between the weapon and its wielder, showing just how advanced Minato's control over his chakra really is. The design of the kunai also reflects Minato's philosophy in battle. Unlike the standard single-bladed ninja tool, his three-pronged variant represents balance, control, and adaptability. The prongs help stabilize the weapon mid-flight, making it spin with precise aerodynamics, and they double as grip points for quick retrieval during close combat. Every aspect, from its weighted handle to the sharp symmetry of the blades, is optimized for both throwing accuracy and multi-purpose use. This attention to design makes it more than a weapon. It's a manifestation of how intellect and instinct can coexist in perfect harmony. The kunai becomes a bridge between science and spirit, a symbol of how mastery, when combined with innovation, creates something truly extraordinary. Another remarkable aspect of Minato's kunai is the way it connects instinct with calculation. Every time he wields it, it's not just a throw, it's a carefully planned move, executed with flawless timing. The placement of his kunai across the battlefield is a reflection of his foresight and strategic depth. He doesn't rely on raw power. Instead, he builds an invisible network of advantage points that allows him to outthink his opponents. The precision of his throws, the memorization of each kunai's position, and his ability to visualize spatial geometry in real time turn combat into an art of motion and intellect. It's as if he's solving an engineering problem mid-battle, optimizing distance, angle, and reaction time all at once. A perfect example of intelligence meeting physical skill in its purest form. The creation of this kunai in SolidWorks begins with a simple sketch. But as always, the magic lies in how each feature is layered to form a complex and detailed shape. The process starts with the revolve command, used to generate the central body of the kunai, giving it that perfectly symmetrical and aerodynamic structure that makes it look sharp, yet balanced. Once the main body is formed, the lifted blade sections are crafted using boundary surfaces to capture the unique curvature of the prongs. This step is crucial because the kunai's blade doesn't follow a single flat plane. It bends and flows, and that organic shape is best achieved using surface modeling tools rather than simple extrusions. After defining the blade geometry, the surface knit command comes into play to merge the multiple surface bodies into one continuous shape, making the model watertight and ready for solid conversion. The thicken feature is then applied to give the blade its actual physical volume, converting the thin surfaces into a solid 3D object. For the handle, a combination of revolve and extrude boss/base is used to create its cylindrical and angular transitions, ensuring it fits perfectly into the kunai's overall flow. The ring at the end is another carefully designed element, modeled through revolve and refined using fillets to smoothen the edges, ensuring both realism and manufacturability. The most advanced part of the process is reverse engineering the fine details of the kunai's design, such as the subtle engravings, blade edge tapering, and handle grip. By referencing multiple concept artworks and scaling them proportionally within SolidWorks, the design is built layer by layer to match its anime counterpart. The lift and boundary surface features help replicate the signature blade split, ensuring all angles transition smoothly without distortion. Small fillets and chamfers are applied to key edges to catch the light properly in rendering, emphasizing realism and craftsmanship. The modeling of the kunai's intricate shape heavily relies on lofted features and precise 3D sketching, both of which bring the fluid, organic geometry of the design to life. The loft command is used to transition smoothly between multiple cross-sections, allowing the blade to taper elegantly from the base toward the tip. Unlike a simple extrusion, lofting gives control over curvature continuity, ensuring that the kunai's three-pronged design maintains a natural flow. Each blade section is defined by carefully drawn sketch profiles, one near the base, another mid-length, and a final sharp-pointed section at the end. By connecting these profiles through guide curves, the loft forms a seamless body that captures the aerodynamic and aggressive aesthetic of the kunai perfectly. Creating those 3D curves is another essential step, especially for the outer edges and the connecting surfaces of the prongs. These curves are drawn in 3D space, using reference planes that are offset and angled strategically to define how the surface bends and twists. Once the guide curves are placed, the loft or boundary surface follows them precisely, generating that distinctive wave-like form seen along the blade's split edges. This method allows for fine control over how light interacts with the surfaces, an important detail when rendering the final model to achieve realistic reflections and shading. The sketching process itself is the foundation of everything. It begins with a central reference axis for symmetry, followed by detailed sketches of the blade's profile, the handle outline, and the ring base. Each sketch is fully constrained to maintain dimensional accuracy, ensuring that any modification later in the design does not distort the geometry. By combining 2D and 3D sketches, SolidWorks allows the kunai's complex curvature to be modeled with mathematical precision while preserving the artistic freedom of its anime-inspired design. This balance between technical construction and visual creativity is what makes the project both challenging and rewarding, transforming a fictional concept into a real, manufacturable 3D form. The modeling of the kunai's intricate shape heavily relies on lofted features and precise 3D sketching, both of which bring the fluid, organic geometry of the design to life. The loft command is used to transition smoothly between multiple cross-sections, allowing the blade to taper elegantly from the base toward the tip. Unlike a simple extrusion, lofting gives control over curvature continuity, ensuring that the kunai's three-pronged design maintains a natural flow. Each blade section is defined by carefully drawn sketch profiles, one near the base, another mid-length, and a final sharp-pointed section at the end. By connecting these profiles through guide curves, the loft forms a seamless body that captures the aerodynamic and aggressive aesthetic of the kunai perfectly. Creating those 3D curves is another essential step, especially for the outer edges and the connecting surfaces of the prongs. These curves are drawn in 3D space using reference planes that are offset and angled strategically to define how the surface bends and twists. Once the guide curves are placed, the loft or boundary surface follows them precisely, generating that distinctive wave-like form seen along the blade's split edges. This method allows for fine control over how light interacts with the surfaces, an important detail when rendering the final model to achieve realistic reflections and shading. The sketching process itself is the foundation of everything. It begins with a central reference axis for symmetry, followed by detailed sketches of the blade's profile, the handle outline, and the ring base. Each sketch is fully constrained to maintain dimensional accuracy, ensuring that any modification later in the design does not distort the geometry. By combining 2D and 3D sketches, SolidWorks allows the kunai's complex curvature to be modeled with mathematical precision while preserving the artistic freedom of its anime-inspired design. This balance between technical construction and visual creativity is what makes the project both challenging and rewarding, transforming a fictional concept into a real, manufacturable 3D form. When it comes to 3D printing the kunai model, several software and hardware choices can help you turn your SolidWorks design into a tangible, high-quality replica. Since the model is designed with precision and contains fine details like engravings and smooth blade surfaces, choosing the right combination of slicing software and printer type makes a huge difference in the final outcome. The most practical workflow starts with exporting your SolidWorks model as an STL file, which can then be processed through slicing software such as Ultimaker Cura, Prusa Slicer, or Bamboo Studio. These slices are reliable, easy to use, and give you advanced control over layer height, infill density, support generation, and wall thickness, all essential settings for capturing the kunai's intricate geometry. Cura is a great all-around option for most printers, while Prusa Slicer offers detailed tuning for high-precision prints. If you want even smoother surfaces and accurate edge transitions, using Lychee Slicer or Chai Box with a resin printer is also an excellent choice. For printing hardware, the FDM, Fuse Deposition Modeling method, is the most accessible and affordable. Printers like the Creality Ender 3, Anycubic Cobra, or Prusa i3 MK4 can handle the kunai model easily using PLA or ABS filament. To achieve the cleanest edges and sharper definition on the engravings, you can switch to resin-based SLA printers like the Elegoo Mars 4 Ultra, Anycubic Photon Mono X, or Frozen Sonic Mini 8K. Resin printing offers higher detail resolution and a smoother finish, which is perfect for small ornamental models like this one. If you want to go even more advanced, SLS, selective laser sintering, or MJF, multi-jet fusion, printers such as those from HP or Formlabs can be used for professional-grade results, ideal for collectors or display quality pieces. These machines can reproduce fine surface textures, and since they don't need traditional supports, the triple-blade geometry of the kunai prints cleanly without post-processing distortion. Once printed, post-processing steps like sanding, priming, and painting bring the model to life. Metallic silver spray for the blade and matte black or dark gray for the handle can give it a realistic anime-inspired finish. Using clear coat varnish afterward enhances shine and durability. Whether you print it with desktop FDM equipment or professional resin machines, the final piece becomes a stunning fusion of anime artistry and engineering craftsmanship, a physical symbol of what creativity and precision design can achieve together. Rendering the kunai model is where all the hard modeling work truly comes to life. It's the step that transforms a precise CAD design into a visually stunning, photorealistic object. In SolidWorks Visualize or KeyShot, you can create professional quality renders that make the kunai appear as if it's been crafted from real metal, complete with reflections, shadows, and subtle imperfections that bring authenticity. The goal during rendering isn't just to make it look shiny, it's to make it believable. The process begins by applying accurate materials and appearances to every component. The blade, for example, is assigned a brushed steel or polished titanium material with fine directional texture mapping to mimic the way light scatters across real metal. The handle can be given a matte carbon fiber, rubberized black, or anodized aluminum finish, depending on the visual tone you're aiming for, rugged, sleek, or ceremonial. If the kunai has engravings or embossed markings, adding bump maps or normal textures subtly enhances their depth, allowing light to catch the grooves just like it would in a real-world engraving. Lighting setup plays a major role in achieving realism. Using a three-point lighting system, key light, fill light, and rim light, you can highlight the sharp contours of the blade and define the silhouette of the handle. In SolidWorks Visualize, using HDRI, High Dynamic Range Image, environments adds realistic reflections of ambient surroundings, making the blade look naturally integrated into its virtual scene. A cool-toned HDRI gives a stealthy, futuristic vibe, while a warm, studio light environment makes the model feel hand-forged and traditional. Camera composition is equally important. You can create depth of field effects to blur the background slightly, focusing on the blade's tip or the engraved ring, giving the render a cinematic look. Experimenting with focal lengths also helps. Shorter focal lengths can emphasize perspective and make the kunai look dynamic and powerful. Meanwhile, close-up renders of the engraved text or edge bevels showcase your design precision and attention to fine detail. Post-processing further refines the final image. Tools like Adobe Photoshop, Lightroom, or even DaVinci Resolve can enhance contrast, add color grading, and adjust brightness for a more polished look. Subtle highlights, motion blur, and glow effects on metallic edges can be used to suggest movement or energy, something that anime fans especially appreciate as it gives a sense of action even in a still image. When done right, the rendered kunai looks less like a CAD model and more like a collectible straight out of an anime set, reflecting craftsmanship, precision, and storytelling all in one frame. The power of rendering lies not just in showing what you've designed, but in making people feel the character and creativity behind it. To make the kunai truly authentic and capture that distinct anime-inspired aesthetic, one of the most impressive touches is adding engraved symbols onto the handle through image-based embedding in SolidWorks. This step turns the model from a technical 3D object into a personalized artistic creation. Instead of sketching each marking manually, an image decal or emboss technique is used, allowing intricate characters, runes, or stylized emblems to be transferred directly onto the model's surface, just like the symbolic engravings seen on collectible replicas. In SolidWorks, this is done by first preparing a high-contrast black and white image of the desired symbols or inscriptions. The black areas define what will be engraved or embossed, while the white areas remain untouched. This image is then imported as a sketch picture and aligned perfectly with the handle's curved surface. Once positioned, the split line or wrap tool projects the image geometry onto the surface, converting the flat artwork into 3D contours. From there, you can use extruded cut or emboss features to etch the design at a specific depth, shallow enough to maintain detail, but deep enough to catch the light during rendering. For even higher realism, surface wraps work perfectly on the handle's round geometry. The wrap feature ensures that the engraved image flows naturally along the curve, without distortion or stretching, making it look like the symbols were carved directly into the metal. The result is a clean, professional finish that looks engraved rather than printed. During the rendering phase, applying a brushed metal or matte texture with subtle bump mapping enhances the realism, letting shadows form inside the engraved lines to make them stand out visually. The beauty of this technique lies in its versatility. You can experiment with different symbols, emblems, or even fictional scripts to give the kunai a custom identity. Whether the engraving represents a clan insignia, a serial marking, or just an ornamental design, this process blends art with engineering precision. It's the perfect example of how CAD design allows creative storytelling through geometry, letting you embed personality into every curve and edge of the model. In anime terms, the kunai's creation would have been far more than a simple act of metal forging. It would be a process filled with meaning, mastery, and precision that borders on artistry. Every aspect of its design suggests that it was crafted by someone who understood balance, weight distribution, and the harmony between speed and stability. The triple-bladed structure wouldn't be random. It would be deliberately engineered to cut through air resistance with minimal drag, giving it both speed and accuracy in flight. The handle, with its distinct ring and engraved markings, would serve as both a balance point and a symbolic representation of control, where raw power meets calculated intent. In the anime universe, such a weapon wouldn't just be made of ordinary steel. It would likely be forged from a specialized alloy designed to conduct and store energy, in this case, chakra, allowing it to respond directly to its wielder's intent. The engravings on the handle wouldn't just be decorative, they'd be inscribed seals designed to synchronize with the user's energy signature. When imbued with chakra, the kunai could act as an extension of the body, enhancing motion, reflex, and accuracy far beyond human limits. This combination of engineering logic and mystical energy gives it both a mechanical and spiritual presence, making it a perfect bridge between science and imagination. From a craftsman's perspective, creating such a kunai in the anime world would require a deep understanding of metallurgy, geometry, and chakra flow, a process that might involve multiple stages of forging, folding, and imbuing under precise temperature and energy conditions. The metal would be heated repeatedly and folded to align with the wielder's chakra pathways, forming a structure that resonates on a molecular level. The ring at the end would be more than ornamental. It would act as a stabilizer for energy dispersion, allowing the kunai to maintain balance even under intense movement or when infused with chakra during combat. If translated into our modern design perspective, this concept aligns perfectly with the principles of engineering: balance, precision, aerodynamics, and structural integrity, all of which can be replicated through SolidWorks modeling. Every sketch, fillet, loft, and engraved detail in the CAD model symbolizes a piece of that fictional craftsmanship. The curvature of the blade represents aerodynamic optimization. The symmetrical design ensures balance. The engravings reflect the spiritual and artistic dimension. In a way, the SolidWorks model doesn't just recreate the kunai visually, it reverse engineers the craftsmanship that the anime suggests, transforming creative fiction into a piece of functional, engineered design. This harmony between imagination and engineering is what makes designing such objects so fascinating. You're not only recreating a symbol from a beloved series, you're understanding its design logic, how it would function if it were real, and how precision tools like SolidWorks could be used to replicate its creation process in the real world. It's a tribute to creativity, discipline, and the beauty of bringing an idea from fantasy into engineered form. When every curve, angle, and marking of the kunai finally takes shape, it feels like watching engineering and art merge into one, a perfect balance of form and function. What makes this design so special is not just the way it looks, but the logic behind every detail. The sharp symmetry of the triple-bladed design isn't arbitrary. It gives the weapon aerodynamic stability, allowing it to travel straighter and faster through air if it were real. When we zoom into the engraved handle, we see how much story a small set of markings can hold. In the anime, the symbols represent more than mere decoration. They're personal, intentional, and deeply tied to the wielder's identity. Each line, curve, and stroke seems to pulse with purpose. In SolidWorks, that emotion is translated through image wrapping and embossing, a digital equivalent of engraving steel. The wrap tool allows the artwork to bend perfectly across the handle's curvature, maintaining both alignment and clarity. Once extruded or cut, the symbols catch shadows under the render lights, creating a dynamic texture that makes the kunai look handcrafted. What you see on screen begins to feel tangible, as if you could reach out and feel the grooves under your fingertips. If we imagine this weapon being made in the anime's world, it wouldn't be forged through mere heat and hammering. It would be the result of patience, technique, and balance. The creator would choose a special alloy capable of conducting chakra, a kind of spiritual energy, allowing the kunai to resonate with its wielder's life force. The engravings would act like pathways, channeling that energy throughout the blade, making it more than metal. It would become an extension of the user. The ring at the end would serve not only as a physical stabilizer, but also as a spiritual conductor, a place where the flow of chakra begins and returns, creating a continuous loop of control and connection. The handle would be carefully wrapped or shaped to fit the wielder's grip, ensuring that the kunai could be thrown, caught, or maneuvered with perfect fluidity. Its triple-blade design wouldn't just look striking, it would create controlled turbulence when thrown, improving both flight speed and directional accuracy. The split edges would hum softly as they sliced through the air, a faint vibration produced by the perfect harmony between design and energy. Even the balance point, precisely placed between the ring and the start of the blade, would be optimized for motion, letting the kunai spin and stabilize mid-air. This level of consideration in design mirrors what engineers do in SolidWorks, analyzing weight distribution, testing shape continuity, and refining proportions for optimal performance. When translated into the real world, the SolidWorks process replicates this philosophy. The kunai begins as a simple sketch, a few lines defining the silhouette, and slowly evolves into a masterpiece of geometry. The loft command creates the flowing transitions of the blade, while 3D curves guide the exact curvature of each prong. Surface knit ensures that the individual surfaces merge seamlessly, producing a continuous, smooth finish. Boundary surfaces fill in complex regions with precision, and thicken transforms those paper-thin surfaces into a realistic, solid body. Every edge is fine-tuned, with fillets and chamfers, simulating the craftsmanship of hand-polished metal. And when the final model is ready, it stands as a testament to both modern CAD capabilities and the timeless art of design. In rendering, the story continues. Using SolidWorks Visualize or KeyShot, the kunai can be brought to life through lighting, texture, and environmental effects. The blade is coated with a brushed steel texture, the handle a matte carbon finish, and the engravings enhanced with micro-surface bumps that catch light beautifully. With HDRI lighting, reflections wrap naturally around the blade, simulating daylight or studio environments. A soft rim light enhances the blade's edges, emphasizing its sharp geometry and giving it that cinematic look, as though it's glowing faintly under battle-ready tension. The camera focus narrows on the tip of the blade, blurring the background to create a sense of depth and realism. If we were to imagine this kunai lying in an anime workshop, freshly forged, resting on a stone pedestal, the light would glide gently over its edges, highlighting both craftsmanship and character. It would look like the perfect blend of science and spirit, the precision of an engineer fused with the imagination of an artist. And through SolidWorks, that vision becomes possible in our world too. The 3D model isn't just an object on screen. It's a bridge between fiction and reality, built through skill, curiosity, and the love of creation. Projects like these remind us why CAD design is so powerful. It's not only a tool for engineers, it's a creative medium for dreamers, storytellers, and innovators. Designing the kunai teaches symmetry, proportion, and form. But it also teaches vision. It encourages creators to think like both artists and engineers, to see how a simple idea can evolve into something complex, meaningful, and real. Every click of a mouse, every adjustment of a curve adds a piece of personality until the final model feels alive, carrying both its cultural legacy and the creator's touch. And that's the essence of what we do here. Every project at Blueprint Bazaar combines imagination with precision, storytelling with structure, and creativity with engineering. Whether it's a weapon inspired by anime, a machine designed for industry, or a concept that pushes design boundaries, our goal is to make every model a bridge between what's imagined and what's possible. So, if you've enjoyed exploring the creation of this kunai, from its history and symbolism to its SolidWorks design and rendering, stay tuned for more. We'll keep bringing you projects that merge the worlds of creativity, engineering, and design innovation. Thank you for watching. This is Blueprint Bazaar, where engineering meets imagination, and every design tells a story. Please keep supporting us as we dive deeper into mechanical design and development. Don't forget to like, share, and subscribe so you never miss a step on this engineering journey with Blueprint Bazaar.